In this video I'm going to use the common LFO as an alternate modulation source and use it to control pitch changes. So what's an LFO and what is the common LFO? LFO is short for low frequency oscillator. Now an oscillator is a piece of electronics that will produce a sound that swings like a pendulum between one setting and another. And that swing could be a regular swing in pitch, it could be a regular swing in tone, or it could be a regular swing in volume. When a signal swings between the two fixed points, it is oscillating. How frequently it oscillates is known as its frequency. And the number of swings or cycles per second is measured in hertz. So a 440 hertz signal is a signal that swings 440 times per second, and that's concert pitch A. A note that swings at 880 cycles per second, or swings per second, is an octave above. So you can see the relationship between the frequency of these oscillations and the pitch. That's an oscillator, and an LFO is simply a piece of electronics that produces low frequency or very slow oscillating sounds that swing between 2 points. And it can be used to produce a number of different effects, such as vibrato, panning, regular swings in volume or tremolo, and regular tone changes like a wah-wah effect, for example. If we can use an LFO as an AMS source, we can get other settings to move in sync with the swinging of the LFO between its widest settings and get them to do so at the same speed. Vibrato is an obvious example of a sound that swings evenly back and forth between two pitches, oscillating in pitch. So we could have a sound with vibrato and get it to change in volume and tone in time with the swinging of the LFO where we play a note, for example. If you've watched my earlier videos, you'll know that the Kross has two sample-based sound sources that it calls oscillators, and these are used to create its basic sounds. The output of both of these oscillators can be fed into their own separate low-frequency oscillators. Each oscillator has two LFOs, and the result can be manipulated further by combining the output signals through yet another LFO, which is common to both and hence referred to by Korg as the common LFO. I've used the Unison square lead preset again, pressed the menu button and scrolled down to the P pitch page again. I've tabbed down to the AMS setting and changed the amount in the AMS setting to +12 again, but this time I've set the AMS source to common LFO. The preset sound I'm using already has LFOs programmed to work in it, so if you press a key you'll hear an LFO at work already. That regular change in pitch. Listen to how it swings or oscillates between the lowest pitch of the note you play and the note an octave higher. This is because the pitch is following the movement of the LFO. Now I've just pressed the menu button and scrolled down to the P Common LFO / KT settings. The first tab is the LFOW tab, and with this you can set different LFO waveforms, hence the W. They'll create different types of oscillations and oscillating effects. But before we're going to go anywhere near that, let's go to the LFOF tab, which is next to it, by tabbing across using the page plus keys. Use the dial to alter the frequency and set it to about 50. And what you'll notice that as I adjust the dial, the frequency of those oscillations changes. That's set to 50. Now return to the LFOW tab with the page minus button. I'm not going to go into any depth about the different wave shapes or wave forms at this stage. That's for a video on the LFOs. But press and hold the key and scroll through using the dial. can see the different waveforms having different effects on that sound. They're still creating oscillations, but they're creating different forms of oscillations. The waves that you're hearing are basically named after the way they look on an oscilloscope, and most of them look like they sound. The sine wave flows neatly, for example, whereas the square wave works almost like an on-off switch, causing pulsing rather than flowing changes to the pitch of our note. Now, particular waveforms are useful for producing specific effects, but again, that's for another video on LFOs. To see what the different waveforms can do, try setting the frequency at 91 on the LFO F tab. Set the LFOW, the wave, to random sample and hold, or random SH number 1. That should be a very familiar random sample hold effect that can be heard on Dark Side of the Moon by Pink Floyd. This is a video about AMS, so I'm not going to go into the rest of the settings for the LFO, other than to mention the AMS setting, which you can see on there, which is presently set to off, and the reset LFO setting, which is also set to off. I've set the AMS reset to tempo, and I've set the frequency of the oscillator to 51, and I've used the square wave to create a pulsing sound. And I'm using the tempo knob there to reset that LFO, or basically interrupt it in mid-flow and then get it to start again. So that's what that reset control does. You'll notice that the AMS shape setting option is greyed out. This is because the parameter cannot be used with a square wave or with some of the random wave settings. The shape settings can smooth out changes between oscillations, so a triangle, which is a fairly abrupt shape, can be smoothed out into something a little bit more like a sine wave, which is a lot smoother. Now, the square wave is meant to create really abrupt changes, so Korg figure, why would you want to shape it? I've just set the wave to step saw 4 and the AMS source to pedal 04. Press a note and you'll hear the regular move of the step wave. I've set the pedal intensity to 99, and as I introduce the pedal, you'll see that the shaping of the wave is being created by the pedal. The sound's still oscillating, but the wave is being manipulated in the middle of the swinging to emphasise particular high or low frequencies within that sound. On some of the waves you won't particularly hear it make that much difference, but it's there. To give you an idea of what the phase control on this thing does, this is the step saw 6 wave. You can hear how it's starting from that highest pitch point and working its way down. What I'm going to do is I'm going to change the phase. I'm going to set it at 180, which basically means it's going to start halfway through that cycle. So it's not starting through at the same point every time. So it's still going through the same cycle, but it's starting at a different point in that cycle. To show you what the offset control is doing, I'm going to use the guitar because it's very difficult to actually hear what it's doing quite clearly on the keyboard. But I've got a guitar. I'm causing an oscillation. Now if I play like that, I'm offsetting the start of the oscillation, and that is all the offset control is doing. You need to listen to it quite carefully and adjust the settings, but basically it's creating a period where nothing happens other than the playing of the note, and then bringing the oscillation in slightly later.